Dear friends, I'm Dr. Anthony Leung from the Chinese University of Hong Kong, and I would like to share with you about the Thulium Fiber Laser, the new standard of intracorporeal lithotripsy. This is my disclosure. In the past 20 years, Thulium laser is become the standard in lithotripsy because of the effectiveness. It can almost breaking all the stone, and also its flexibility because of the use of small fiber that can reach different parts of the intravenous calyx, and also it's safe and also versatile. However, it had also some limitation, including its noise, and also for high power machines, it's quite heavy and also demanding special electricity supply. So why Thulium laser had this problem? This is partly related to the design of CUMISSC laser, because for current machine, we are using the flash lamp, either xenon or krypton, that is to shine the light on the chromium doped yak crystal. And because the light produced are broad spectrum light, so therefore only around 7 to 8% of the light are being absorbed by the crystal. Therefore, a lot of the energy are lost and wasted into high temperature, and the energy efficiency are quite low. And also for the single tube machine, they can only producing low power, like less than 30 volts and also less than 30 hertz. Therefore, in order to producing high power generator, we may need to combine several tubes together to generate a high power energy. However, for this multi-tube system, we will require the use of vapor compression refrigerator system to cool down the machine, and therefore it will be resulting in the big size machine and also more noisy and also more electricity demand. So we need something better. Looking into the periodic table, we can find that next to the chromium there will be thulium. And in fact, Thulium Fiber Laser is one of the new laser systems that have been developed to try to replacing the chromium yak laser. The difference in design including the use of diode laser to generate the light for the laser machine, and also the thulium molecule are being doped in the fiber compared to doped in the yak crystal. The advantage of using thulium is that it has a much better absorption by water, and the thermal expansion of water trapped in the stone will help to improving the stone fermentation. And actually, this absorption is much better than chromium by 4 times. And this effectiveness in the use of energy is not just limited by this better water absorption. It has other advantage compared to the chromium laser. For example, because we are using the diode laser, we have the wavelength similar to the yak laser. Therefore, the energy absorbed will be more effective, and therefore the heat loss will be less. And because of that, we can build on some higher power machine like more than 50 volts and also high frequency up to 2000 Hz in just a single tube machine. And because of that, single tube usually will be good enough to produce effective energy, power, and frequency for stone fermentation. And therefore, the demand for power supply and also ventilation or cool down system will be less. This is a comparison about the energy or electricity demand for the two systems. You can see that for the Thulium Fiber Laser, we are using just usual electric plug, while for the CUMISSC laser machine, the high power machine, we need to have special high power energy provided to it. And also the ventilation system is much smaller for the Thulium Fiber Laser compared to the much bigger ventilation system for the CUMISSC laser. And that's resulting in a much bigger machine, much heavier machine compared for chromium laser compared to the thulium laser. And in fact, it's almost 6 times the weight for the full chromium high power laser compared to the Thulium Fiber Laser. So this better in the energy absorption and also machine design will be transferred to the better clinical outcome. So we first look into the basic laser parameter difference between the two systems. For the Thulium Fiber Laser, and because of the better energy efficiency, and therefore actually it can producing much wider range of the energy range, and also producing pulse duration much longer. And the use of this long pulse may help to decreasing the stone propulsion. And also, as mentioned before, much higher frequency can be produced up to 2000 Hz. And this parameter will help to improving the better stone fermentation, resulting in much smaller residual fragment, and ideal for dusting. And also, because of the lower energy or lower heat production, less fiber tip degradation will be the result. And this so-called the super dusting, you can see that for the use of Thulium laser, because of the use of high frequency, and we can producing very fine dust, which will be easy to be flushed out by the body, and without the use of some basket or other stone retrieval device to take the stone out. Besides that, also because the pulse duration and the pulse shape is quite different between the Thulium fiber laser and also the holmium. In fact, because of the electrical modulation, the pulse producing by the Thulium fiber laser is much more plateau, more flat pulse shape compared to the pitch-shaped holmium laser pulse. And because of this more steady changes in the pulse pitch, it will be resulting in less stone propulsion. Therefore, this will be another advantage of using Thulium fiber laser with less stone movement or retropulsion. How about the clinical application result? In some in vitro study, and compared to observing the effect of the Thulium fiber laser and holmium fiber laser in fermenting stone, we can see that for fermentation of the uric acid stone under the same setting, for holmium laser compared to Thulium fiber laser, we can see that for all the comparison, Thulium fiber laser have a much better ablation rate compared to the holmium laser. And if we set into the dusting mode with a low energy and high pulse rate, again we can see that for the use of Thulium fiber laser, no matter if the short pulse or long pulse for holmium laser, the ablation rate is much better for the Thulium fiber laser when compared to the holmium laser short pulse or long pulse. How about stone retropulsion? We can see that under different setting, the stone movement, the retropulsion is much lower in the Thulium fiber laser compared to the holmium laser in both the short pulse and also the long pulse. And you can see that in different other in vitro or ex vivo study, the benefit of Thulium fiber laser have also been confirmed by having a much higher ablation rate and also less retropulsion. How about in clinical application? This is a video showing how the laser works. You can see that when you're using the Thulium fiber laser, actually the stones are almost not moving during the stone fermentation, and very fine dust are being produced during the fermentation. And so this is the dusting effect. And if we set into a more fermentation rate with higher joules and 20 Hz, you can see that the stone fragments are much larger compared to the dusting mode. However, again, you can see that the movement of the stone as the retropulsion is quite minimal. And this is the benefit of the use of the Thulium fiber laser. And actually, the stone almost stayed there without any movement. So in fact, currently already there's multiple studies comparing the use of Thulium Fiber Laser with chromium laser. And you can see that no matter it's with or without the use of MOSES technology, the stone-free rate is more favorable to the Thulium Fiber Laser when compared to the chromium laser. And also, when we look into the postoperative complication, actually, the use of Thulium Fiber Laser and chromium laser is about the same. Therefore, the use of Thulium Fiber Laser, despite its more effective and more high frequency, it didn't really resulting in any detrimental effect to the patient. Therefore, in conclusion, with the rapid development of the endoscopic technology, and laser lithotripsy have become the key energy device for stone fragmentation. While chromium laser have been used for more than 20 years, and however, it has some intrinsic problem that limit its further application. The newly developed Thulium Fiber Laser have providing us a more effective energy usage, longer pulse rate, and also higher soft frequency, which could allow a better stone fragmentation and dusting, and also less stone propulsion. And this characteristic or benefit of the Thulium Fiber Laser had already been proven to be really benefit in our patient in both in vitro and clinical study. Therefore, it will probably become a new standard in endoscopic lithotripsy in the near future. Thank you.